We are due. Forget Yogi Bear. Okay, forget Old Faithful. It's sitting on top of a sleeping giant. It could destroy the United States as we know it.
The western region of the U.S. is home to a sleeping monster. It periodically stirs, but it hasn't awoken from its sleep in about 70,000 years. But when it does awaken, it may howl and heave with a power that has never been seen before. With its jaw-dropping attractions, Yellowstone has long been a hive of excitement and attracted throngs of visitors. But now, says famous scientist Michio Kaku, there's another reason to be cautious while you explore. Knowing that Yellowstone National Park is perched atop an active supervolcano raises the possibility of an eruption. Is the volcano in Yellowstone dangerous? Can we survive an eruption at Yellowstone? Join us as we find out exactly what's going on at the national park and if there's anything we can do to stop it. The oldest national park in the world, Yellowstone is not merely a treasure of the United States. Yellowstone, which opened its doors in 1872, spans 3,472 square miles, 8,987 square kilometers, across 3 states. Nearly 3 million people visit the park each year to take in the breathtaking natural scenery, which features the Old Faithful geyser, as well as numerous hiking trails, mountain peaks, and hot springs. Not to mention the variety of wildlife such as grizzly bears, moose, elk, beavers, and bighorn sheep that make the park home. But beneath the surface of this haven for outdoor enthusiasts, there lies another natural marvel that could make the park extinct. The Yellowstone supervolcano, which is miles below the surface of the park, is a significant source of granitic magma. For those who enjoy the outdoors and numerous people who live close to the park, a full explosion would be devastating news. That magma chamber has occasionally erupted over history. The last eruption at Pitchstone Plateau took place about 70,000 years ago, and the vast great bulk of those eruptions in Yellowstone have been smaller lava flows. However, the remote probability of disastrous super eruptions is the reason Yellowstone receives so much attention. A super eruption is defined as any eruption with a volcano explosivity index magnitude of 8 or above and an ejection volume of at least 1,000 cubic kilometers or 240 cubic miles. That would bury Texas 5 feet beneath the surface. Even the largest eruptions we are accustomed to are thousands of times less powerful than these super eruptions. A heated region of rock that is molten or semi-molten and is known as magma lies beneath the ground above the Yellowstone supervolcano. The ground swells as magma flows into a magma chamber or reservoir that is located 610 kilometers, 6 miles under the park. The ground collapses as the magma starts to harden and cool. Volcanologists who have been monitoring this activity since 1923 estimate that between 2004 and 2009, the ground rose by around 25 centimeters, 9.8 inches. But in 2010, the ground started to sink. Many experts, like Michio Kaku, are speculating as to whether Yellowstone may erupt soon given its recent period of gradual, steady growth. Concerns have been raised regarding the potential intensity of the eruption if it occurs. What to expect if Yellowstone begins to tremble tomorrow is the big question. A 500-year flood occurred in Yellowstone on the morning of June 13, 2022. In 24 hours, the northern areas of the park received 7.5–9.5 inches of rain and snowmelt combined. The north entrance road between Mammoth Hot Springs, Wyoming and Gardner, Montana, as well as 3 parts of the northeast entrance road between Lamar Valley and Cook City's Silver Gate, Montana, were both completely devastated by the flood. The park was able to repair damaged wastewater lines, restore power within 48 hours, and plan for recovery and the eventual restart of operations. 9 days after the flood catastrophe, on June 22, 2022, the park's South Loop reopened. Over the course of the summer, more road and backcountry trail segments opened as repairs went on. However, the degree of recent subterranean activity feeds conjecture about how powerful an eruption will be. The volcano has risen at the quickest rate ever observed over the last 10 years. In addition, Yellowstone experiences between 1,000 and 3,000 earthquakes a year. Most have magnitudes of 3 or less, making them essentially undetectable. However, these earthquakes help scientists understand how quickly the magma chamber beneath the park is expanding. A recent infusion of magma into the reservoir may be indicated by an increase in the shaking and rattling heard throughout the park. Geologists find it challenging to forecast what exactly is happening in Yellowstone because no one has been around to thoroughly examine everything that takes place there. Examining the volcano's distant past does offer a hint of sorts. According to geologic data, Yellowstone has seen 3 massive eruptions in the last 2.1 million years. According to volcanologists, the eruptions happened at intervals of between 600,000 and 800,000 years. The last major event is thought to have occurred about 640,000 years ago, and there is evidence of it throughout the park and thousands of kilometers of the surrounding area. The majority of the continental United States was blanketed in large volumes of volcanic ash, gas, magma, and other volcanic debris from each of the prior eruptions. There have been some materials discovered as far away as Louisiana. Following each of these eruptions, the Yellowstone supervolcano fell in on itself, engulfing the surrounding terrain, including all of the trees, mountains, and other features. Calderas are the depressions created by this occurrence. In actuality, the Yellowstone caldera and Yellowstone supervolcano share the same name. In Yellowstone, a caldera-forming eruption would pose a huge natural hazard. According to scientists, the most recent Yellowstone explosion was 1,000 times more powerful than the infamous 1980 Mount St. Helens eruption, which destroyed hundreds of square kilometers of land in Washington and Oregon and claimed the lives of 56 humans and thousands of animals. The last eruption of the Yellowstone supervolcano sent a deadly plume of hot ash, molten rock, and deadly gases thousands of meters into the air thousands of years ago. There's a good chance that the entire continent went completely dark. Fast-moving currents of hot, dry rock fragments and gases known as pyroclastic flows raced through the area at startling rates, burying or crushing anything in their path. The once beautiful scenery was scorched for miles by magma erupting from the earth. The 50 kilometers, 30 miles wide, and 70 kilometers, 45 miles long Yellowstone caldera itself contains some remnants of the most recent eruption. In a region known as the Lava Creek Tuff, one can still observe the thick volcanic debris that was left over after the eruption. Geologists have discovered evidence of at least 47 super eruptions throughout Earth's history. Therefore, Yellowstone is not the only supervolcano in the world. The most recent took place about 26,000 years ago at Lake Taupo in New Zealand. More significantly, the tectonic plate movement led to the enormous Toba eruption that occurred 74,000 years ago. According to others, this precipitated a severe 6 to 10-year global winter and may have all but wiped off the human species. Although it's not an unbreakable rule, the Earth has typically experienced one super eruption every 100,000 years. How might a Yellowstone eruption appear then? A minor eruption in Yellowstone that resulted in lava flows and perhaps a normal volcanic explosion is the eruption scenario that is most likely to occur. As the magma rose to the surface, this would probably be caused by a cluster of earthquakes in a particular area of the park. Now, the warning indicators would be considerably more obvious in the event of a much larger super eruption. Michio Kaku predicted that the entire park would likely experience significant earthquake activity first. Before an eruption, it might take those earthquakes weeks or months to fracture the rocks above the magma. What if we had a super eruption, which was 1,000 times more powerful than a typical volcanic eruption, spewed at least 240 cubic miles of material, lasted weeks or months, and was characterized by prolonged activity? Within the park, the lava flows themselves would be restricted to a circumference of about 40 kilometers. In actuality, only about 1/3 of the material would enter the atmosphere. Volcanic ash, a mixture of shattered rock and glass, which was thrown kilometers into the air and dispersed throughout the nation, would cause the majority of the damage. Scientists came to the conclusion that an eruption would produce an umbrella cloud that would grow evenly in all directions based on past ash dumps as well as sophisticated modeling. This discovery actually caught us off guard. The Northern Rockies may theoretically be covered in 3 feet of ash by a super eruption, which would obliterate major portions of Wyoming, Idaho, Colorado, Montana, and Utah. A few inches of ash would fall on the Midwest at the same time, and much less would fall on the coasts. The precise distribution would be based on the season and the weather. Any of those possibilities would be awful news. Ash and debris don't seem like such a bad thing, do they? In fact, it only takes 3 to 4 feet of ash to completely damage infrastructure, buildings, and modes of public transit. Many lives would be lost, and air traffic would come to a complete stop. Even a small amount of ash can have fatal effects on the respiratory system, make driving hazardous, and cause the death of several crops and animals. Most of North America would have to stop using airplanes. A volcanic eruption would be easy to predict based on how many earthquakes it was preceded by. Even though there are already a lot of earthquakes in Yellowstone National Park every year, they are nothing compared to the tremors that precede an eruption. Evacuations would be required because it would be clear that the park and the adjacent villages had been destroyed. Lava flows should assist the Yellowstone volcano make its message if earthquakes weren't clear enough. Thankfully, lava flows can't spread as far as ash can, and blazing hot lava is most likely to harm a maximum of 50 miles of Yellowstone National Park. In contrast to blazing hot lava, there is one more unexpected consequence that volcanic eruptions have on our planet: an exponential drop in temperature. Such a large volcanic eruption would also have significant impacts on the world's climate. Sulfur aerosols released by volcanoes can reflect sunlight back into the atmosphere, lowering temperatures. There is no way to predict the exact amount of ash and debris that will be discharged into the air during a Yellowstone volcanic eruption given its possible scale. Any level of volcanic activity, though, sends particles into our atmosphere that deflect and prevent glaring sunlight and UV rays. This results in a drop in temperature, and a Yellowstone supervolcano may spew forth enough of these particles to significantly lower the planet's temperature for several years. Given the current temperature of the Earth, this may sound like a good thing, but the abrupt change to cooler temperatures would probably be disastrous enough to change crop and agricultural production. No matter how powerful it turns out to be, a supervolcano eruption the likes of which Yellowstone may conceivably create will change the planet. If the Yellowstone supervolcano were to erupt, molten rock just below the surface of the ground would start to melt as a result of heat rising from the planet's core. As a result, a brew of magma, rocks, vapor, carbon dioxide, and other gases would be produced. The pressure finally forced the ground up into a dome shape and produced fissures around the borders as the mixture accumulated and grew over thousands of years. The dissolved gases would blow up when the pressure was released via the fractures, quickly spreading the magma across the park. A 10-foot, 3-meter coating of molten ash may be projected to extend 1,000 miles, 1,609 kilometers away from the park and kill as many as 90,000 people instantly. Rescuers would undoubtedly have difficulty entering. Similar to what happened in Iceland in 2010 when a much smaller volcano erupted, the ash would seal off all points of entrance from the ground, and the spread of ash and gases into the atmosphere would halt the majority of air transport. When Pinatubo erupted in 1991, it temporarily lowered Earth's temperature by around 1 degree C, 1.8 degrees Fahrenheit. A few regions may have experienced famines as a result of the Tambora eruption in 1815, which caused enough cooling to harm crops all over the world. It's challenging to imagine the magnitude of a volcanic superexplosion. Many of us recall the 1980 eruption of Mount St. Helens, which sent ash as far as the center of the United States and smaller particles all over the world. However, the amount of ash and debris created by the Mount St. Helens eruption was only around 1/10 of a cubic mile. According to historical data, Mount St. Helens produced much less debris than the earliest supervolcanic eruptions at Yellowstone, which happened millions of years ago. In fact, almost 900 cubic miles of debris and ash were produced by the 3 massive eruptions that created the 3 calderas in Yellowstone National Park. What are the chances of a super eruption in Yellowstone? There are currently no indications of an impending eruption. Although there are still earthquakes in Yellowstone Park, and the ground is still rising and falling, this is nothing unusual. The odds of Yellowstone exploding in any given year are 0.00014%, according to the USGS, which is lower than the likelihood of being struck by a civilization-destroying asteroid. Even so, it's not a reliable estimate because there's no guarantee that Yellowstone explodes on a predictable cycle or that another eruption is imminent. Super eruptions will occur on Earth in the future, but will Yellowstone experience any of them? That can't be guaranteed. Indeed, volcanoes eventually fade out. The heat rising from below and the relative cold from the surface are 2 opposing forces acting on the magma chamber beneath Yellowstone. The chamber might theoretically freeze and finally transform into a solid granite body if the heat from below is reduced. Additionally, it's important to keep in mind that the volcanic hotspot beneath Yellowstone is progressively moving to the northeast, or more precisely, that the North American tectonic plate is moving southwest over the hotspot. If enough time passes, the hotspot will leave Yellowstone's foundation, and the supervolcano there will presumably cease to exist. Of fact, a second supervolcano could form much farther to the northeast, but that wouldn't happen until the hotspot warmed up and melted the crust, and it can take 1,000,000 years or longer for that to happen. It's difficult for us to comprehend something like 1,000,000 years. The human species is a recent one. However, these systems take a very long time to operate, and Earth has been around for a very long period. Thanks for watching another episode of Voyager. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space.